Good evening students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with the question number 6 of chapter 12 Electricity, class 10, CBSE NCERT. So let us start with the question number 6. It says a copper wire has diameter 0.5 mm and resistivity of 1.6 into 10 power minus 8 ohm meter. What will be the length of this wire to make its resistance 10 ohms? How much does the resistance change if the diameter is doubled? Okay, so in the first part we need to find out the length of the wire having the resistance equal to 10 ohms, and the second part we need to find out what will be the effect on the resistance if the diameter is doubled. So let us start with the first part by finding out the by finding out the length value. Okay, so let us start by finding out the length value. So in order to find out the length value, we should know the formula for the resistance. Actually, the resistance of a wire is directly proportional to the length and is inversely proportional to the area. So R is given by rho L upon A. So from here we can calculate L value. So L will be equal to RA upon rho. Okay, L will be equal to, A will go on that side and get multiplied by R, and rho is in multiplication with L right now. When it will go on the other side, it will get divided. Okay, so with this formula we will be finding out the value of L. Okay, now we have been given to us that the copper wire is having the diameter equal to 0.5 mm. Now diameter is given in the millimeters, so we need to convert it into meters first. So it will be equal to 0.5 into 10 power minus 3 meters, and since the radius is given by d by 2, so the radius will be equal to 0.5 into 10 power minus 3 upon 2. So this radius we are going to will be putting in the formula and finding out the value for the length. Okay, now area is always given by pi r square. So we know that the value of pi is 3.14. You can also put 22 by 7, no problem in that, into r square. R square will be this value only, 0.5 into 0.5 into 10 power minus 6 upon 4. Okay, r square is this. Okay, we have done the double of the radius. Okay, now let us put all the values in the formula for the length of the wire and find out the length of the wire. Okay, so length will be given as R. R is given as 10 to us. Area is this whole value, will be substituting over here. Okay, upon 4, and the rho value is also given to us as 1.6 into 10 power minus 8. Okay, so ultimately we are left with these much values over here. So let us solve them. When this will go towards the numerator side, the sign of minus will get positive. So above there would be okay, so this gets cancelled, also this gets cancelled. So 10 power 8 minus 6 into 157 into 25 into, in the numerator we are left with this, okay. In the denominator we are left with 32 into 10 power 2. So after solving it, we'll be getting 122.6 meters. And if we round off the value, it will be equal to 123 meters. Okay. So our value of length of the wire which is having the resistance 10 ohms is equal to 123 meters from here. Now, in the second part, we have been asked that how much the resistance change. So actually, area is directly proportional to R. Okay, area is, because area is given by pi r square. Okay, so when the diameter is doubled, the area is the radius is also doubled. Okay, so when d doubled, R also doubled. Okay, so let the previous area be A1 and the new area be A2, or we can write A old and A new. Old is equal to pi r square, but A new, area new will be equal to pi into 2r whole square. So after dividing it, A old upon A new, we will be getting over here pi r square upon pi 4r square. So r square gets cancelled, pi gets cancelled, and we are left with 1 upon 4. So we can say that a new area is equal to 4 times the old area. New area is equal to the 4 times the old area. Okay. So A new is equal to 4 times the old area. Now we have got a relationship for the areas. Okay. Now we can easily see that resistance is directly proportional to length, but resistance is inversely proportional to area. Okay. Resistance is always directly proportional to length, but resistance is inversely proportional to area. This point is to be noted over here, and it is to be kept in mind always. So we can easily say that R old is directly proportional to 1 upon A old. Okay, is direct proportional to 1 upon A old, or we can say R old is inversely proportional to A old, and R new is always also inversely proportional to A new. So when we will divide both the values, we will be getting from here R old upon R new will be equal to A new upon A old. Okay, and A new value is equal to 4 A old. So I'll be substituting the value A old upon A old. So this gets cancelled from here, and I'm left with A old is equals to 4 times A new. Or I can say that from here I can say that R new is equal to 1/4 value of R old. Okay. So the resistance will change 1/4 times. The resistance will change 1/4 times, and the new resistance will be 1/4 of the old resistance value. Suppose the value of over here is 10. Now if we double the diameter, then the radius will also will be doubled, will get doubled, and when the radius will get doubled, the resistance value will change to 10 upon 4. That means it will change to 1/4 into 10 upon 4. Okay, so this is the effect of doubling the diameter. When we are doubling the diameter, the radius is also doubling. Okay, and the area is becoming 4 times. Area is becoming the 4 times of the previous area, or we can say of the old area. Okay, and when area is becoming 4 times, because the resistance is directly proportional to length but inversely proportional to area, so the resistance value is becoming 1/4. Resistance value is becoming 1/4. So this is only the effect of the doubling of the diameter. Okay, so now let us move on to the question number 8. Question number 8 says, when a 12-volt battery is connected across an unknown resistor, there is a current of 2.5 milliamperes in the circuit. Find the value of the resistance of the resistor. So we need to find out the value of the resistance of the resistor. Okay, so 12-volt battery is given, and we have been given that there is a current of 2.5 milliamperes. Okay, so current is given to us as 2.5 milliamperes. That should be connected into that should be converted into amperes. So it will become 2.5 into 10 power minus 3 amperes. Now milliamperes is converted into ampere. Okay, and now we have been also given to us the value of V, which is 12 volts over here. Okay, and we need to find out the value of R, resistance value. So we are very well versed with the Ohm's law. V is equals to IR. V is equals to IR. We are very well known with the Ohm's law. This is the Ohm's law, which says that at constant temperature and pressure, the voltage is directly proportional to current. It says that voltage is directly proportional to current, and when we remove this proportionality sign, there is a constant which is equal to resistance over here. Okay, so with this formula we can easily find out the value of R. R will be equal to V upon I. Okay, V is given to us as 12 volts upon I. We have already converted into amperes over here. So it will become 2.5 into 10 power minus 3. Okay, so when we will remove it, we will be getting from here 4.8 into 10 power 3. When this will go to the numerator, the sign of minus will change and get positive. So it will become into 10 power 3. Okay, this is ohms. So we can also write therefore the resistance value, resistance of the resistor is 4.8 kilo ohms. We can also denote it by kilo because 10 power 3 is 1000 and 1000 denotes a kilo. Okay, so it is kilo ohms, and this is only our answer. Okay. Okay, so in this manner we need to do these types of questions. So thank you. So please subscribe my channel, and if you have any doubt you can ask me in this comment section. Thank you.